Gentlemen, lesson 3-4, using the commutative property to solve equations, getting back to algebra. For now, though, let me pause for a second, pause your video, check out the previous assignment. Come on back when you're ready. Goal for today, take what we learned about using the commutative property. I mean, after all, we could put 80 and 20 together to make 100, make addition quicker, easier. We're going to use the commutative property to solve equations, reorder things. We are not changing the quantity. After all, if you change the order of additive expressions or multiplicative expressions, you'll have the same expression. And then just make connections to the previous lessons about solving equations. Now, sooner or later, we're going to get into some heavy stuff, some multi-step equations. But again, the goal would be to change order or groupings to simplify things first and then get into solving. All right, go ahead and pause your video. Whatever the date is, whatever the assignment number is, pause your video, write the page and the numbers, and come on back when you are ready. All right, remember in all things, as we've always talked about, solving equations is very similar. An equation is like a scale. An equation is a mathematical statement in which each side of the equation is the same as the other. So if I were to take a scale and I were to draw, well, I'm not going to sit here and draw 55 pluses, but I guess I could. I'll do a dot, dot, dot. And then we got 39 pluses. Oh, and by the way, we also have this money bag full of money. One thing that I would like to do is to change the order of the X and the 39. Now that's not going to change really the, allow me to erase that. If I were to put that money bag right here and move over the 39, you'll notice that that scale is still going to be balanced. It's still the same quantity on each side. We have 55 on one side, we have 39 on the other. But now we have an equation that we know how to solve. We can simply take away 39 from both sides, of course. Careful with that, take away 39 from both sides. If we have 39 and we take away 39, some of you have a small weakness of not crossing those inverse operations out. That's okay. Meanwhile, 55 minus 39, if we did 55 minus 40, that'd be 15. But that went down one too far, so instead of 15, we're going to call that 16. Or is it? Now, when I rewrite the equation, instead of writing 39 plus some missing number, we believe we know what that missing number is. We think it is 16. Now we'll go ahead off to the side. Don't do fake checking. Actually check it, folks. No joke. I've had some people. Let's just make up a number. They say 55 equals 39 plus 20, and they say good. No, wait a second here. If you actually checked it, you can find the mistake. 39 plus 20 is 59. That's a false statement. Those are not the same quantities. So no fake checking. If you find a number, substitute it in, go off to the side, and actually add them up. In this case, 9 and 6 make 15, carry the 1. 1, 3, and 1 is 5 tens. And so we end up with 55 is the same as 55. Now that is a true statement. Some people put a check mark, some people put true. No fake checking, ladies and gentlemen. All right, onward to the next problem. Now, I've seen some of you do this, right? W times 9. I don't know if you learned that at a previous grade level or not. It's not bad, but listen, you wouldn't come up to me and say, hello, Callan, mister. I mean, that's me, but it's not the best way to say it. You would say, hello, Mr. Callan. In like manner, with algebraic expressions, you always want to put the coefficient first. Now, remember the commutative property of multiplication states you can change the order and still have the same product. So I'm not, in fact, changing the quantity here. But I am setting up an equation now that we already know how to solve. So divide both sides by 9, be fair. Of course, 9/9 makes one whole. And as previously stated, you can write the 1. You don't have to. That's up to you. Come off to the side, let's go ahead and divide. 9 goes into 14 one time with 5 left over. And if we were to subtract 4, 9 goes in, or bring down the 4, excuse me, 9 goes in 54 6 times. We think we know our answer. Or do we? No fake checking, right? Now, in this case, this is going to be weird, but I'm going to rewrite the equation just as we saw it. Some number W times 9 is 144. But now we think we know what that W is. We think that W is 16. So I'm going to substitute in and let's find out. Going off to the side, 16 times 9. 6 times 9 is 54, carry the 5. 9 times 1 plus 5, 14. And we quickly see this to be a true statement. A little bit of disappearing ink, folks. Don't forget, problem. Write the original problem, then show your work with your solution. And of course, don't forget the check step. Some folks forgot how to check. Just simply rewrite the same equation down below and substitute in the number. Rewrite the exact same equation down below, but now substitute in the number that you think is correct. All right, your turn, ladies and gents. Go ahead and pause, rewind if you need. But what I'd ask you to do right now is solve numbers 3 and 4, examples 3 and 4, and come on back, pause your video, solve them, come on back when you are ready. All right, so the first thing I would do is I would change the order of number 3. I would change the order so that H comes before the 12 and 3/10. And now, how do we get rid of that 12 and 3/10? Well, we're going to subtract 12 and 3/10 from both sides. In doing so, you'd get an answer of 28 and 7/10, or is it? So we're going to go ahead. We're going to rewrite the original equation, but now we're going to substitute in what we believe that H amount is. Instead of writing 12 and 3/10 plus H, we're going to write 12 and 3/10 plus 28 and 7/10. Go off to the side, actually check it, and yes, 41 and 0/10 is the same as 41. That's true. For number 4, I'm also going to change the order here. Now, in fact, some of you might even put 8C on the left side and 34 on the right. We can talk more about that later. Meanwhile, I don't want to know what 8 envelopes of money are. I want to know what a single envelope of money is. So we go ahead and divide not just one side, but both sides by 8. Remember, if an equation is a scale, keep it fair and balanced. If you divide one side by 8, then make sure to divide the other side by 8. Now, of course, 8/8 makes 1 whole C, not that you have to write the 1. 34 and 8/10, 34 divided by 8 is 4 and 25/100, and we can check it. Rewriting the equation exactly as we see it, but now we're going to substitute. Instead of some mystery number, C times 8, we think we know what that mystery number is. And it turns out that 34 is in fact the same as 34 and 0/100. That's a true statement. No fake checking. Make sure you check your work. And of course, we have the problem. We have our work step. We have our solution that we're circling. And then we check it. That's all I have for now, folks. Whatever the date is, whatever the assignment is, go ahead and draw a line underneath your notes. Begin examples. You need notes. You need notes, ladies and gents. That was some ugly cursive. Don't worry about that. Sooner or later, we're going to get you into two-step equations where you have to get rid of not one, but 2 different quantities to really solve for x and what x is. I'm wondering how many of you can model this equation out with 3 x's and then 7. Some people put 1s, some people put plus symbols, and then 22, of course. I could just draw this out, but I wonder if you really understand what equations are. We're heading to two-step equations coming soon, but for now, go ahead, take care of this assignment, do well, let's grow. See you.